so remember yesterday we looked at our mean value theorem, and basically our setup is very similar to our other mean value theorem. Okay, and remember that our mean value theorem for derivatives, okay, says that at some point, okay, the average rate of change has to equal the instantaneous rate of change. Yes, at some specific c value. And the same is true for our intervals. Basically, what we're saying is that if I take the average, okay, at some c value, so basically that's just kind of creating like a box, basically, a rectangle, that has to equal the instantaneous or the exact value of my interval. So I think we kind of talked about yesterday that basically it ends up being at some point the area that is above this value equals out with the area that is below. So my negative and my positive kind of cancel each other out, and we're just left with that same exact value. So you'll see these questions worded one of two ways. One, they'll actually ask you to like find the c value that makes this true, and we'll look at one like that. But the second way, and the one that's actually more like applicable to like real world stuff, is that if I'm looking at something that is changing constantly, okay, I can't just find an average value by adding them all up and dividing by how many we have. So what we end up having to do is find an average value. I'm going to take 1 divided by b minus a times the interval, and that's going to give me the average value there. And we'll look at one like that as well. That should be value. So it says find the average, and I'm about to change it. Not a c. Of a value of the function on 1 to 4. Basically, we're looking at f of c, okay? Remember, f of c is my average value. Basically, I'm looking at the average y value. That's why we have an f of c and not just c, okay? Equals, what's our formula? Let's go ahead and write it out again. 1 divided by b minus a times from a to b of f of x dx. Okay? So what are my a and b here? 1 and 4. So I have 1 divided by 4 minus 1 times the interval from 1 to 4. And my function is 3x squared minus 2x dx. And then from there, we're just evaluating this interval the same way we've been evaluating it. I'm just going to multiply by 1/3 at the end. Well, so what is the antiderivative of 3x squared? And the antiderivative of negative 2x? Okay, and we are evaluating from 1 to 4. Are we okay with that? Yes? Okay. So then what is 4 cubed? Minus 4 squared.
16.
Okay. Minus, so I'm going to put a big bracket around my 1/3. 1 minus 1. Agreed?
Yeah.
Okay, so we get 0 there?
16.
Yeah, are we okay that we get 0 here?
Yeah.
Okay. So we said we get what on the inside? 64 minus 16 is?
48.
48, okay. Times 1/3 gives us? 16. So the average y value, okay, is going to be 16 for that function. Now, but again, remember that is f of c. They did not ask us at what c value that happens. Does that make sense?
So if it's the average, does that mean there could be multiple c values?
Correct. That is true. That is a good point. what's gonna happen on there is, so like, let's go ahead. So if I wanted to know the C value that this happens at, what would we do?
We just put it, like we plug it in on the left, and then we just solve
Left where?
of the original one.
Yes. So like we would just set our original equation equal and then solve. Yeah.
Oh yeah, we finished our original.
Yeah. We said that we would find our f of c, which is our y value, set it equal to our original equation, and then we would say that c equals whatever. Does that make sense? And like this is a quadratic, so there would be two places that it happens, most likely, right? But what do they give us? An interval. So we would need to make sure that whatever, if we got two values, one, both of those values were in that interval. And most likely they're not going to be. Only one of them is going to be. So let's look at one where we are solving for our c value. So this says find the c value guaranteed by MVT for the interval negative pi over 3 to pi over 3 for f of x equals cosine of x. So again, basically we're going to start it the same way, okay? I want to find my f of c first, okay? And then whatever we get there, we're just going to set that equal to my original one. Which again, these steps are kind of similar to what we did with our derivatives, right? We found our average value, and then we set that equal to our derivative in that case to figure out where our c value is. It's just here we're using our intervals this time instead, which is why they both have the same name. So, I have 1 divided by, what is my b?
Pi over 3.
Okay, minus a negative, so that ends up being positive pi over 3. Are we all okay with that?
Yeah.
Times the integral from negative pi over 3 to pi over 3 of cosine of x dx. What is 1 divided by pi over 3 plus pi over 3?
3 over 2.
1 divided by 2 pi over 3, which is also 3 over 2 pi. Alright. So then, what is the antiderivative of cosine? Sine. And we are evaluating that from negative pi over 3 to pi over 3? Yes? Okay. Which one do we want to plug in first? The top one. Okay. Now what is sine of pi over 3? No to both of those.
Square root of 3.
It's square root of 3 over 2. Okay. Now, negative pi over 3 is still going to have a reference angle of pi over 3, but now it's going to be in our fourth quadrant, which means that sine is what? Negative. So we will have a negative, and I am subtracting, so we end up with a positive square root of 3 over 2. Are we all okay with that? Yes? Okay. So if I have 2 square roots of 3's over 2, what do we end up with? Just the square root of 3, which means that we get 3 square roots of 3 over 2 pi. Now we're going to leave it like that for right now because that is not going to be a pretty number. We have an irrational radical and we have a pi. So it's just going to be doubly decimally fun. So this is going to be 2 square roots of 3 over 2, right? So my 2's are going to reduce. So my parentheses here is just going to be square root of 3, and so then I just multiply. So Now remember, this is our average value, but they did not ask us for the average value this time. They asked us for the seed value that makes that happen. So what do we need to do with that?
Plug it in to our original.
Where? On our original equation.
Or, yeah, on
The
the
f of x, yes. How do I solve that?
right.
Take the inverse. Now, if this was a non-calculator active question, that is our answer. Okay? Because really, up until here, besides hopefully us needing to remember that these are square roots of 3, right? None of this has been super complicated numbers. Yes? As long as we leave stuff exact. Okay? So this would be where we would stop if it was a non-calculator. If it was a calculator active, then we just plug that into our calculator. And what do we get? I'm assuming that's in radians, yeah. Which notice, why would we want to be in radians? Because we're going from negative pi over 3 to pi over 3, right? So they gave us a question in radians, so we want to have an answer in radians. Alright. Other questions. So I want to look at not that one. I want to look at a word problem. Because like I said, this is where that application portion comes into play, is looking at the average value of functions that actually represent doing stuff.
When it says f of c, like that's the average value, is that like take f of c, like original, or is that like derivative f of c? Which f?
It would be the average value of your original function. So technically the antiderivative of whatever is on the inside there. Correct. So let's look at I don't want to type it all out, so I'm trying to find it. Okay. Now, before we flip out, this is going to be a calculator active question. Okay? Well, they're not very pretty numbers, so I didn't want you to be like, oh, those are super ugly. Yeah, they are. Alright.
These are the times when we need gas.
No, this is very, very easy question. So that's why I want to go over it now, because I don't want us to get it. Like, we should get this 100% of the time. Alright? So it says, the volume in liters of air in the lungs during a 5-second respiratory cycle is approximated by the model V equals 0.1729 T plus 0.1522 T squared minus 0.0374 T cubed, where T is the time in seconds. Approximate the average volume of air in the lungs during one cycle. So, we are going to need to take our integral of this. Yes?
Yeah.
Okay. We also need to to figure out what our bounds are. What does it tell us? 0 to 5. It says a 5-second period, or 5-second cycle. Okay, it's going to be this model that we have right here. Yes. And then because I'm wanting the average, what do we also need to do? 1 over b minus a, which is going to be 5. Right? So if it asks you for the average value, okay, please be careful, because what a lot of people want to do is plug in 0, plug in 5, get those two answers and divide by 2. Okay, but again, if my volume is always changing, I cannot do that. Does that make sense? So we are going to use our calculator. You're going to want to have a graphing calculator. I'm going to show you how you plug all of this in.
Dang it, you wanna draw me your name? I'm like snap the land.
My favorite is mid-chemistry assignment.
Hey! You're going to go to math. You're going to click number 9.
F and down F and
0 does do intervals.
0, 5.
We need to know how to do one. It will only do definite intervals, right? Like I have to put in boundaries. So if I have an indefinite interval, it doesn't really help me to use
Do we have those?
what?
Indefinite intervals?
Yeah, that's what we did first. Remember where we just took the antiderivative and we had to do the plus c.
Oh, okay.
Right?
Yeah.
So your calculator won't do that, okay? And then also remember you will have a non-calculator active portion of your test. So you need to know how to do this base. But like you want to know how to do it in our calculator as well, because we don't want to spend time calculating all of this. Because what's going to happen on my test and the AP test, if it is a calculator active portion, basically it is going to be 1 point, okay, that you set up an interval. And then it is going to be 1 point for the final answer. So whether you do it by hand and do all of that work, that's not very much fun, okay, and get the right answer, or you just typey all of it into our calculator and get the right answer, you would get the same result. So when we are in the calculator act portion, we do not want to waste time doing stuff like that, right? Okay, so we are going from 0 to 5. And then we're going to type 0.1729. You're going to use your X button that is underneath your mode plus 0.1522x squared minus 0.0374x cubed. And then you want to put another X after where it says D, because you're saying that that's the variable we're using to take the antiderivative with respect to. You get something that looks like 2.659167. But remember that that is just the integral part, so then I just need to click divided by 5. So what do we get? 0.53. For what?
Oh, yes, got it. Also, we need our significant difference. We have 4.